Hi, this is Mr. King again, and welcome back. We're working on section 6.5b, graphing inequalities in a coordinate plane. I want you to note, not every inequality comes in the slope-intercept form. Remember, the slope-intercept form is y equals mx plus b. But some of our inequalities come in other forms. The x may be on the left-hand side of the inequality. So we have to change it. So let's take a look at our example. Our example is 5x plus 2y is less than negative 2. So we are going to put it in the slope-intercept form. You must put it in the y equals mx plus b format. So let's take our equation. So what do we normally do? We're going to subtract 5x from both sides. When you do that, our equation now is 2y is less than negative 5x minus 2. Now you might say that is in the slope-intercept form, but it's not in the slope-intercept form because it is important to note that you must solve for only one y, because slope-intercept, remember, is y equals mx plus b. So we're going to get rid of this 2. We're going to isolate the variable y by dividing by 2 throughout the inequality. If we divide by 2, we now have y is less than negative 5 halves x minus 1. We have it in the slope-intercept form. Remembering that the m part of the slope-intercept form is our slope, and our b part is our y-intercept. So we come over here to graph it. We go down to a negative 1, right? And our slope is negative 5 halves, so it's down 1, 2, 3, 4, 5, and then over 2. Or if you want, you can go up 1, 2, 3, 4, 5, and over negative 2. And we now have, we used a dotted line because it is just less than. And remember, if it is less than, we're going to graph below the line that we have. This is the graph of y is less than negative 5 halves x minus 1. Let's move on. All right, we have a reminder. As a review, all rules apply. So if you divide by a negative number, you flip the inequality symbol, just as we've done in all the work we've done up to this point in our program. Secondly, you always solve for y. And y comes first in the inequality because we want to have it in slope-intercept form. Now let's look at some unique inequalities. Let's take a look at this example. 4x is less than or equal to 16. At first glance you say, well, that's not in slope-intercept form. How are we going to graph it? We can still graph it, but it's not going to be in slope-intercept form. So we're going to divide both sides by 4. 16 divided by 4 is 4. So let's graph it. It says x is less than or equal to 4. We come over here to where we see 4. 1, 2, 3, 4. We're going to put a solid line because it's less than or equal to 4. And what we're saying is all our values of x at this point are less than 4. 3, 2, 1, 0, all the negative numbers, they are all less than 4. We're not really dealing with the y values, we're just concerned with the x values here. Now let's take a look at a practice problem. Our inequality is negative 3y plus 6x is less than 9. What I'd like you to do is, I'd like you to turn off the video for a minute. I want you to complete this inequality, graph it, and then turn the video back on and check your answer. Okay, so turn it off now, please. Okay, welcome back. Let's solve this inequality. Our first step, we are going to put it in slope-intercept form. So we are going to subtract 6x from this side and subtract 6x from this side. We now have negative 3y is less than negative 6x plus 9. Okay? It's in slope-intercept form, but remember, we only want one y in slope-intercept form here. So we're going to have to eliminate this negative 3. Since a 3 next to a y means we're multiplying, we are going to divide. We're going to divide by a negative 3. If we divide by a negative 3 here, we must divide by a negative 3 here, and we must divide by a negative 3 here. And our final answer then becomes y. Remember, we divided by a negative 3. What do you have to do to your symbol here? We must reverse it. We must flip it. It's now greater than. A negative divided by a negative is a positive. 3 goes into 6 2 times, 2x. A positive divided by a negative is a negative, and our answer is 3. We now have it in slope-intercept form here. So let's graph this inequality here. We're going to go to the negative 3. We're going to come down 1, 2, 3. We're going to put a dot here at negative 3. Okay? And our slope is a positive 2. We're going to go up 1, 2, and over 1. And up 1, 2, and over 1. Up 1, 2, and over 1. We look to see, are we putting a solid line or a dotted line? We are going to put a dotted line because it does not include the numbers on our line as part of the solution set for this inequality. Okay? And the last thing it says is, are we greater than or less than? Because if it's greater than, we're going to shade in above. And if it's less than, we're going to shade below. It is greater than, so we are going to shade in above. And all of our answers that satisfy this inequality will be above this dotted line. Let's check it out. Let's pick a value here. Let's pick the value. We could go with 0, 0. There's an ordered pair. 0, 0. So if I substitute 0 in here, 0 is greater than 2 times 0 minus 3. 2 times 0 is 0, right? So is 0 greater than negative 3? The answer is yes. So we're saying all of our solution set will be above the line of our graph 4. And this is the graph of y is greater than 2x minus 3. Thank you.